Hello everyone. So today we will talk about another dynamic diagram which is UML sequence diagram. So now this sequence diagram is actually a part of interaction diagram. So what is an interaction diagram? Interaction diagram is actually describes some types of interaction among the different elements in your model. So you can easily understand that the sequence diagram will actually describe some types of interactions in your model, in your system. Okay, and as there is interactions, so that means it has dynamic behavior, right? So that's why this is a dynamic it falls into the category of dynamic diagrams. So we have two interaction diagrams actually. One is sequence diagram and another is collaboration diagram. Okay, and among these two, sequence diagram are most preferred. So in this lecture we will focus only on UML sequence diagrams. UML sequence diagram actually models the interactions between objects in a single use case. So it's actually use case specific. It depends on the use case. You will illustrate how the different parts of a system interact with each other to carry out a function and the order in which the interaction occurs when a particular use case is executed. So sequence diagram actually will contain all the objects in your use cases, the participating objects, their flow of messages, their communication between them, their time sequences. So that's why UML sequence diagram is actually little different from the other UML diagrams. So now let's talk about the key elements in the sequence diagram. So this diagram is actually structured in such a way that it represents a timeline which begins at the top and descends gradually to mark the sequence of interaction, right? So that's why it will contain some objects and each object has a column, and it will contain some messages which will show the communication between them. So the messages will be exchanged between them and it will be represented as arrows, and there are axes like horizontal axis and vertical axis. So we will talk about each of these in details in the next slides. So the first one is participating object, right? You will have objects in your sequence diagram. Object is individual participant in your sequence diagram, and we already know how to represent the objects in we have learned it in object diagram, right? So now here it's also same. You have to draw a rectangle box first, and then you have to give the name of your object, and you will underline the name. Okay, and the naming format is the same. At first you will write the object name, then you will put a colon, and then you will put the class name. But if you have any object of unknown class, then you can just put then you can just write the name of the object, that's fine. And if you have any anonymous object, then you can just write the class name. So that's the naming conventions, and you will underline it. So that's how we represent an object. Now each object has a lifeline. Okay, you must have to add a lifeline in your object with your object. Okay, so the lifeline is actually represented by a dashed vertical line. This is the vertical axis, and it represents the lifeline of that individual object. Okay, so this is how we represent our object in sequence diagram. So I have already mentioned everything here. Each object has a lifeline. So yeah, these are three individual objects with three lifelines. Now let's move how these objects communicate with each other. So the communication between objects is depicted using messages. Okay, and the messages appear in a sequential order on the lifeline, and we represent messages using horizontal arrows. Okay, so we have to write message name and argument above the arrow. That's how we represent message. Lifelines and message, these two are the main or core elements to create a sequence diagram. So now we have to learn about different types of messages. The first one is synchronous message. So in synchronous message actually waits for a reply before the interaction can move forward. So the sender waits until the receiver has completed the processing of the message. And the caller continues only when it knows that the receiver has processed the previous message. Suppose it receives a reply message, then it will continue. A large number of calls in object-oriented programming are synchronous, and we represent synchronous message using a solid arrowhead. And the next one is asynchronous message. An asynchronous message does not wait for a reply from the receiver. The interaction moves forward irrespective of the receiver processing the previous message or not, and we use a line arrowhead to represent an asynchronous message. We have another message, that is reply or return message. Reply messages are used to show that messages being sent from the receiver to the sender. We represent a reply or return message using an open arrowhead with a dotted line. And the next one is reflexive or self message. So while you draw your sequence diagram, you might have some scenarios where the object needs to send the message to itself. Such messages are called self messages or reflexive messages. And it is represented by a U-shaped arrow. So in the next page we have given all different kinds of notations for those different kinds of messages. For synchronous message we use a solid arrow with a solid head. For asynchronous message we use a solid arrow with a stick head. For return message or reply message we use a dashed arrow with stick head, and for self message we will use a U-shaped arrow. So these are 4 different types of messages. We have two more different type of messages. We will show it later. So now let's talk about activation bar. So activation bar is the box placed on the lifeline. You can see in the figure that there is a box on the lifeline. So these box actually represent activation bar. So it is used to indicate that an object is active during an interaction between two objects. And the length of the rectangle indicates the duration of the objects staying active. In a sequence diagram, an interaction between two objects occurs when one object sends a message to other. So the use of activation bar on the lifeline of the message caller and the message receiver indicates that both are active during the exchange of the message. And we can also have nest activations in activation bar. Nest activation actually indicates that an object is calling itself. So here the second figure is showing nest activation. Now we will talk about object creation and object deletion. Remember I told you that we have 2 more messages. So along with object creation and object deletion, we will discuss about 2 more messages, okay? Objects actually do not necessarily live for the entire duration of the sequence of events. Sometimes you have to create objects later in your sequence diagram. So you will find situations when a particular message call requires the creation of an object. That message is called create or new message. That's another kind of message, okay? So at that time the message is represented with a dotted arrow, and it will be labeled with create or new word. Okay, that's called create or new message. That's the create or new message symbol. So the new object that you have created, it will appear lower than the others to represent that it has created later. So if the created participant does something immediately after its creation, you should add an activation box right below the participant box. So as you have created a new object, likewise that you will have situations where the participant is no longer needed in that situation. In that case, you can delete that from a sequence diagram. So you can do this by adding a X at the end of the lifeline of that participant. So in that figure you can see at the end of the activation bar we have put a X to indicate that this participant is no longer existent in this sequence. So there are two different messages. One is create or new message and another is delete message. So now we will talk about frame or fragment. We use this when our sequence diagram is a little bit complex, then we use this frame. Okay, so a sequence fragment or frame is represented as a box that frames a section of interaction between objects in a sequence diagram. We use this frame when we have complex interactions in our sequence diagram, such as alternative flows or loops. If your program has loops, then you can use this frame to represent your sequence diagram in a more structured way. So here on the top left corner of the fragment we have an operator. Okay, so this is the frame will be represented as a rectangle box, and on the top left corner of that box we will put an operator. This is called fragment operator, and it specifies what sort of fragment it is, whether it's a loop, whether it's a option condition, whether it's an alternative combination. So then this fragment operator is actually representing what kind or what sort of fragment it is. Then we have another element that's called guard condition. That is actually the condition, like the condition of your for loop, the condition of your if else. That condition is called guard condition. So the condition you are checking, that means the condition of your if or the condition of your loop, the condition you are checking is the guard condition. So let's talk about the first one. The first one is option. It's actually if condition. So the option combination fragment is used to indicate a sequence that will only occur under a certain condition. Otherwise, the sequence won't occur. So that means it models only the if statement. If there is some sort of condition, and then this block will occur. But there is no otherwise, like there is no else condition, just the if condition. So that's an option combination fragment. The option combination fragment is represented with a rectangular frame where you will put opt. It will be placed inside the name box, that means the fragment operator box. Okay, on the top of the left corner you will put opt as the fragment operator. This is representing option fragment. And the next one is alternative combination fragment. It actually represents if else condition. So the alternative combination fragment is used when a choice needs to be made between two or more message sequence. It models the if then else logic. Okay, the alternative fragment is represented by a large rectangle or a frame, and it is specified by mentioning alt at the top corner as a fragment name, as a fragment operator name actually. And then if you want to show two or more alternatives, then the larger rectangle is divided by using a dashed line. So here in our figure we have used alternative combination fragment, and then it's divided in half by using a dashed line, okay, because it has two conditions, if and else, so that's why it's divided into half. So if you have more alternative conditions, you have to divide it in more sections. Now we have one more thing to represent, that is guard condition. So each operand has a guard to test against it, and it is placed at the top left corner of the operand. So here the value is greater than 1000. This is a guard condition of the alternative frame. Okay. So the next one is loop condition. So the loop fragment is used to represent a repetitive sequence, and you have to place the word loop in the name box, and the guard condition have to put near the top left corner of the frame. So here in this figure it says for each line item. So this is our guard condition for the loop frame. So now we have another kind of fragment or frame that's called reference fragment. You can use the reference fragment to manage the size of a large sequence diagram. If you cannot fit your sequence diagram in one sequence diagram, then you can use it. Also you can use reuse here. So if you want to reuse part of the sequence diagram in another, then you can use this reference frame. So to specify the reference fragment, you have to mention the word ref in the name box of the frame, and the name of the sequence diagram that is being referred, it will be inside the frame. Okay, so here in the first figure we have given such an example of reference frame. And also you can give comments in your sequence diagram. Okay, like here in the second figure we have shown that if you cannot fit your sequence diagram, if it's too large, then you can just put a comment like this. Okay, but when you draw sequence diagram, you have to remember one thing, that you cannot add too much. Okay, you have to draw smaller sequence diagram that capture the essence of the use case. You have to make sure that the diagram fits on a single page, and you also have to leave space for notes. It's always better to add explanatory notes, and also you just don't put too much to confuse the reader. Just draw a few smaller sequence diagram that explains what your system does. Okay, so instead of using one sequence diagram, you can draw few smaller sequence diagram. When you choose sequence diagrams to draw, for the first thing is find out what is common among the scenarios, and then focus on that scenario and draw that sequence diagram. Okay, so yeah, I have already told you how to draw a sequence diagram, what you should draw, what you should focus while you are drawing your sequence diagram. And here when you draw sequence diagram, the first thing you will find out which scenario you need to show, and then you have to find out the objects, the message flows between those objects, the communication between those objects, and the sequence in which the messages are flowing. So these are the things that you have to focus while you are drawing your sequence diagram. So now this is the example of the sequence diagram of our online order management system. So here you see that we have 4 objects, that is customer object, order object, special order object, and normal order object. Okay, and this sequence diagram is showing their message communication, their sequence of communication. Okay, and you can see there is a word or between the special order and normal order. This is actually representing that the message sequence for special order object are the same for the normal order object. Okay, at first we will initialize it with a arrow without any name. So this is the initialization call, but this is optional. Okay, and then the first call is actually the send order call, which is a method of order object, and the next call is confirm, which is a method of special order object, right? So from the customer object to order object, the communication is calling the send order function, and after that the order object will call the method of confirmation from the special order object. So that's why this is another communication. And then the last call is the dispatch call, and it's a self call, right? And dispatch is a method of special order, so that's why this is a self call. And then each call needs a return or reply message, right? So that's why for the confirm call we are returning a reply message, so that's why it's representing as a dashed line. And as we made another call send order, that's why we need one more reply, and that's also showing here as a dashed line because it's a return or reply message. So this is the diagram of online order management system, and this diagram actually describes the method calls from one object to another, and this is actually the actual scenario when the system is running. So from sequence diagram you can see the actual scenario, right? So that's why sequence diagram is more preferred by the developers. So I have added one more example of sequence diagram in this slide. Just read it by yourself. Thank you.